Welcome to Team Vyuha. This is Thirurul Selvan Karunanidhi. I am the team manager of Team Vyuha. Vyuha is a non-profit organization run by undergraduate engineering students at Bannari Amman Institute of Technology. This is our first time participating in RoboBoat competition and developing an autonomous surface vehicle. Since we don't have any prior experience, we need a strategy. To be competitive and complete as many tasks as we could, we have planned to attempt the tasks that involve similar vehicle behaviors. Thus, we are planning to attempt the following tasks: mandatory navigation channel, avoid the crowds, find a seat at the show, and the snack run.
This is Saravanan, Mechanical Lead of Team Vyuha from Bannari Amman Institute of Technology. The mechanical division of Team Vyuha came up with a design which could be one of the best design to compete with the first three tasks to end up with the best result. In the navigation channel task, it is expected that the boat can easily surpass the channel as the dimension of the boat remains lesser than the width of the passage, and the drag remains lower according to the design and analysis of the boat. And in the task of avoiding the crowd, the dimension of the boat remains smaller compared to the provided path. Also, the turning radius, reaction time, and the drag remains better so that the boat can accomplish the task in the best possible way. In the task of snack run, the boat can make a quick run with an optimal speed as soon as it detects the path and makes a quick turn with the best turning radius possible, which can minimize the task accomplishment time.
Hello, I am Santosh, pursuing my second year of electrical engineering in Bannari Amman Institute of Technology. Myself the lead of propulsion team. Since propulsion system plays a major role of our vehicle, we worked with various kind of propulsion systems and achieved accurate control over the propulsion system. We made our boat to perform efficiently in all assigned tasks. First, the task avoid the crowd. ASV will be need to make sharp turns. Our differential steering mechanism helps the boat to perform this task with better stability, which hence improves the maneuverability of the ASV. For the task snack run, a time-based event, the ASV need to maneuver and make a strict turn around the buoy, where our propulsion system helps to achieve a minimal turning radius without compromising its velocity. Also, this skid steering mechanism we use reduces the deviations of boat around the corner, which the planned path given by the control system. Finalizing these ideas, we tested the designed propulsion system in our boat and hence achieved a better result of propulsion both in terms of direction and speed control. By integrating the propeller with the control system, we plan to achieve the turning radius of 2 times the length of boat. Fortunately, we have achieved it and we get a 1.8 times the turning radius, which is compared to the length of the boat. Hence, we got a better yaw rate without compromising in velocity and making the ASV more stable even in sharp turns.
This is Puvyas. I am the control team lead of Team Vyuha. Currently, I am pursuing second year bachelor's degree at Bannari Institute of Technology. First, we have prepared our control system to complete the mandatory navigation channel. The boat must navigate between the gates without colliding with any of the buoys in the required navigation channel. After adding several waypoints, the GPS, compass, and accelerometer automatically detects the navigation information such as heading, latitude, and longitude and update the changes. The L1 control and PID controller will utilize this information to alter speed and acceleration so that the boat stays on course. Furthermore, GPS data is used to create a virtual user interface. The ASV's capacity to detect task aspects with object recognition and decision making is demonstrated in the snack run challenge. This job displays the efficiency of the hull form in conjunction with the propulsion system and the associated maneuverability. The ASV enters through the gate buoys as rapidly as possible and circles the marked buoy and escapes through the same gate buoys.
Hello, this is Krishnan M from Team Vyuha. I am the member of the Electrical Propulsion Systems. As we made just a prototype of a boat, we cannot predict the response of the system to every action. So, we included a failsafe to ensure the safety of the boat in a hazardous situations. Speaking about the competition strategy, the task 1 and task 3, which is nothing but avoid the crowds and snack run, has sharp edges to be turned by our boat, where there is a possibility for the boat to get immersed in water, which leads to the damage in the electrical components present in the boat. And in this kind of situations, the failsafe is used to save the boat and its components from getting damaged.
Hi, this is Tarakeshwar, lead computer vision stream, Team Vyuha. The computer vision team is working on the autonomous navigation of the boat, and computer vision team also works to accomplish the task given by the RoboNation team, integration of sensor and data fusion for autonomous navigation. Our perception team worked in the integration of sensors and object detection. For object detection, we used YOLO V5. These two types of sensor is important to enabling the depth object as well as detection of objects and long distances. Planning team worked on the planning of the boat after the process of perception with the following algorithm. The control subsystem is responsible for accurately tracking the trajectory provided by the planning subsystem. It does so by appropriately adjusting the final control elements like throttle, brake and steering of the vehicle. Control team worked on the establishing communication with NVIDIA Jetson and Pixoc flight controller using serial communication.